So it looks like we've only got one more example in this lesson, and so I'd say we should go ahead and charge ahead with it. So x times dy dx equals y squared minus y. So what do you think about that? That is immediately separable. But we want to find the solution that passes through the points 0, 1, 0, 0, and 1 half, 1 half. Well, forget about that for now. First we want to find the solution for this equation, and it's separable. dy over y squared minus y equals dx over x. So, in order to do that, we might have to rewrite this so we can solve it with partial fractions. On the left side, the right side, of course, is just ln of x, absolute value of x, I should say. Left side's a tricky one, so we have to say that's a over y, this factor, plus b over y minus 1 equals this 1 that's in front of the dy here over y times y minus 1. So multiplying both sides by the LCD here, we get a times y minus 1 plus b times y equals 1. Well, that means ay plus by equals 0y. So a plus b equals 0, and negative a equals 1. So a equals negative 1, b equals positive 1. Only solution. So that gives the equation after integrating. Remember a is negative 1, so it's negative ln of y plus ln of y minus 1. Actually, I should have stuck these both in absolute value. Equals ln of x plus c, and making both sides exponents for e, we get absolute value there. I remember to put the absolute value in like I should have. Oops. Absolute value of y minus 1 over y. Do you remember where that came from? Property of logarithms here. This is ln of y minus 1 over y, the quantity. Of course, it's supposed to be an absolute value, but I did eventually remember to put that in there. That's from a rule for logarithms, which is really a rule for exponents. Equals. Now check out c times absolute value of x. Remember, when I make both sides exponents for that, e to the c is going to be times e to the c, and that's our arbitrary constant. This is actually e to this c. And since it's arbitrary, we don't have to worry about the absolute value symbols anymore. So we got y minus 1 over y equals cx. Well, that's not going to be nice that way to plug in our initial conditions. We have 3 sets of them. It'd be nicer if we could somehow solve this equation for y explicitly. So the first thing to do is multiply both sides by the denominator y. So we get y minus 1 equals cyx. And then we can subtract this from both sides and add the 1 to both sides. So y minus cyx equals 1. Factor on the left-hand side to factor out the y. Y times 1 minus cx equals 1. And finally, we got it explicitly solved. Y equals 1 over 1 minus arbitrary constant c times x. And by the way, since c is arbitrary, that could be a plus in between here and here. It wouldn't make it any different. But what do we know about this? Well, we know we have some initial conditions. When x equals 0, y equals 1. So put in 0 for x, y equals 1. Doesn't matter what value of c. Oh, that's weird. So that winds up being just the horizontal line, y equals 1 as the solution. For the initial condition, x equals 0 and y equals 0, well, y is 0 and x equals 0, that means 0 equals 1. Ah! Impossible. 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 So that's kind of wacky. So we can't find such a c. Remember, if you think back to this one, you know, y equal to 0 does give us the problem. Right? Y equals 1 gives the problem with this too, because remember, it's not continuous if y equals 1, and that's why we don't have an ability. That actually, y equals 1 is a singular solution. And then 1 half, 1 half, well, if we try that, y equals a half goes in here. 1 divided by 1 minus c times 1 half, so 1 minus 1 half c. And this is solvable for c. Multiply both sides by, you see, well, that just means that this would be equal to 2. That simplifies it a lot. And then, so therefore, from that, you can discern that c equals -1, because here we subtract 1 from both sides, and Huh. That's not true. So if we get 1 minus 1/2 c equals 2, that's this denominator equals this denominator, then subtracting 1 from both sides, we get negative 1/2 c equals 1, so c equals negative 2. Thought I had something wrong there. And the solution is, oh, my solution disappeared. Where did it go? I can see where it went. Went over here. If c is negative 2, and we put that in here, for c, we're going to get y equals 1 over 1 plus 2x. And here's the graph of our two solutions. The singular one is this horizontal line, and the other one is this hyperbola. So that's that. Thank you. Thank you. Thank you very much.